Okay, so what I've got set up here is a voltage divider circuit. Now obviously I can't be certain that this is how you had it set up in the lab, but it seems to me that this is how it's going to be set up. There's a sample problem 12, page 133 in your textbook that you can refer to that's basically got an identical setup to this. So I'm pretty sure this is how you would have it set up. But again, you could double check this with your teacher. So this is called a voltage divider, basically because we have, if the temperature of this thermistor isn't fluctuating, so if it's constant, then this thermistor is basically just acting like a normal resistor. And so in that case you have two resistors in series, which means the current flowing through this entire circuit is the same as the current flowing over this resistor and the same as the current flowing over this resistor, which means that the voltage drop is different for each of these two circuit components. And so that if you got rid of this voltage voltmeter, for example, and you just continued another circuit here, you would have a different voltage between these two wires than you would over the entire circuit, for example. So you can also see, also see page 127. And so page 127 just goes through voltage dividers. So we'll stick to the notation that they use in that example. So this voltage from our battery or our power source is V in, so our input voltage. V that you measured over your thermistor is V out, so our output voltage. Okay, so we'll start by just writing down Ohm's law again. And we'll start by writing it down for the input voltage. So V in is going to be equal to, because this is the voltage going over the entire circuit, we know what I is going to be over both of these components. It's the same, so let's just call it I. And again, because this V in is the voltage over the entire circuit, what we want is the total resistance over both of these resistors. So we'll call it R total. And we know what R total is because when the temperature is not fluctuating, we just have two resistors in series. So resistors in series will have R total is equal to R, which is what I've just called this resistor, plus R therm, which is the resistance over the thermistor. Okay, so we know that. So let's rearrange this in terms of I, because I is the thing we don't know here. So we'll write I equals, if we just divide both sides by R total, we end up with V in divided by R total. And this is equal to V in divided by R total, which is just this here. So R plus R therm. actually, what we want in the end is the current, and what we don't know is the resistance of the thermistor. Well, it depends what actually you want to find out. Depends if you, when you're graphing, doing your graphing, if you want to know what the resistance of the thermistor is. Let's just do it both ways. Let's start by doing it this way first. So what we'll do is get rid of the I term, so then we'll just have R therm in terms of the quantities that we know. So the other thing we have here is V out, so we can write Ohm's law for that as well. So we'll write V out is going to be equal I, the same I, because these two components are in series. And in this case, it's just going to be R therm, because that's the only resistor we have across this voltmeter, basically. Actually, one thing that's important to note is that no current passes through voltmeters. Essentially, we idealize voltmeters as having infinite resistance. So then if you take another look at your circuit that you have drawn, it looks as though the current would have to pass through the voltmeter in order to reach the thermistor. That's why it seems like there's maybe a problem with the way yours is drawn. So I could be missing something, so I would double check that with your teacher. But anyways, let's continue with this. So let's write this as, let's again put it in terms of I. So divide both sides by R therm. We'll get I equals V out on R therm. So now we can look at this equation and this equation and note that they have to be the same. They have to be equivalent to each other, because this one's saying I is equal to this and I is equal to this. Right, so they're both equal to each other. So we can say then, therefore, V in on R plus R therm is equal to this V out on R therm. Now what we want to do is get R therm by itself. So then we can figure out what R therm is in terms of things we know, because we know what V in is. V in is 8 volts. We know what R is, it's 1 kilo ohm. We know what V out is for each temperature step, because that's what you measured over the thermistor. So we should just also write something like this. Note that R therm is the same as R therm as a function of T. So it's a function of temperature, remember, because this resistance changes when we change the temperature. We don't have to write it like this, but it's just good. It's good to remember that it's a function of temperature. So you could do this different ways. The way I would do it, I guess, would just be multiply both sides by R therm. Well, let's just do that first. So let's go R therm times V in on R plus R therm will then just equal V out. And then I would multiply by this term at the bottom here, this R plus R therm, which will just take it over to that side. Let's continue that here. Then we'll have R therm times V in equals, and I'll multiply this right out, so it'll be R times V out plus R therm times V out. So I just multiplied both sides by this term on the bottom, just took it over here, and then I multiplied that V out by both of these. I did that because then what I can do is subtract R therm times V out from both sides, because we want R therm, both of these R therms, to be on the same side of this equation. So if we subtract that, we'll have R therm times V in still on this side, minus R therm times V out equals R times V out. Oops, maybe you couldn't see that. So yeah, after doing this multiplication, so I multiplied R plus R therm times on both sides, which took it over to this side, and then I multiplied that V out by R and by R therm here. And then I subtracted R therm V out to get it over to this side, because then what I can do I can take R therm out as a common factor of these two. So that's the same as R therm times V in minus V out equals R V out, R times V out. Then I can just divide both sides by V in minus V out. So I'll be left with R therm on this side equals R times V out divided by V in minus V out. And now we have the resistance of the thermistor in terms of all of the things that we know. Again, we know what R is, it's back up here, 1 kilo ohm. We know what V out is, that's what you measured over the thermistor for each of the temperatures. And we know that V in is just 8 volts. So for example, let me just double check, the first, so we could plug in, so if we want to find what the resistance in the thermistor is, R therm at 1 degree Celsius was the first temperature data point you had recorded, I think. So 1 degree Celsius, let's say that. So I'm just saying R therm like this as a function of T. So now I'm just putting in my T is equal to 1 degree Celsius. So R therm at 1 degrees is going to be equal to R, which we already know is 1 kilo ohm, which is the same as 1000 ohms, times V out. V out was what you measured over the the voltmeter when the temperature of the thermistor was 1 degree Celsius, and so that was 7 volts. So times 7 divided by V in, we know is 8 volts, the voltage from the power source, minus again V out, which was 7. So we end up with 7,000 over 1. So we have, in the end, put our units in there as well, 7,000 ohms or 7 kilo ohms. So that's if what you want is the resistance over the thermistor. The other thing we don't know is the current through the circuit. So we can do the same, we can take basically all the same steps we did here. Maybe this would be a good exercise to do on your own because this video is getting a bit long. So at these points here, so for example for this equation, you can write this one out again, Ohm's law for V in. Whoops. And instead of writing it sort of in terms of I, instead of having your I on the left-hand side here, you'll get rearrange this equation to get your R therm by itself on the left-hand side here. Then do the same with this equation for V out. So that's a bit easier. You can just multiply both sides of this equation here by R therm and divide by I. And then you can write, because those are both going to be equal to R therm now, instead of both equal to I. So then you can do the same thing. You can say, okay, those two expressions that you have on the right-hand side of these equations will be equivalent. So you can write that down. Go through the same steps where you'll get so over here we got our R therm onto the same side of the equation. You get your I onto the same side of the equation. And then pull it out like this because it'll probably be multiplied by 2 terms. Basically go through the same steps and you'll end up with I on your left hand side here in terms of, again, it'll be in terms of R, V out and V in. And so you'll be able to calculate your current over the circuit as well. Cool. Hopefully that helps.